Now let us try to see the different parts used in an voltmeter. So this is nothing but a moving coil voltmeter, and you can see here a bar is written, indicates that this will measure DC quantity, and here also you can see here a line is there which indicates that this is going to measure DC quantity. But when you come to the ammeter, this is an ammeter and this is going to measure the AC quantity. Okay, so since it is an symbol is shown like this, you can confirm that. So now let us try to discuss about the different parts that are used in an moving iron instruments. Okay, so here you can see here, so in order to measure, so this is an moving iron instrument which is nothing but ammeter, which can measure the AC quantity. So how to give the connections is, this is nothing but we are connecting the phase, and this is how to connect the neutral. Okay, and this ammeter is generally connected in series connection. So now when you connect at 5, it can measure the current of 5 amperes. When you shift it to 10th, to this port, automatically it can measure a current of up to 10 amperes. So here the polarities are not much important. Why? Because in AC supply we don't bother about the polarities. So now coming to the scale. So here the scale is an non-uniform scale. So here you can see here 4.5 to 5, this is non-uniformly distributed, and here 1 to 1.5, this is also non-uniformly distributed, and the remaining scale is uniformly distributed. Okay, so that's why these MI instruments are called as non-linear instruments. So now let's try to coming to the constructional details of our moving iron instruments. So here you can see here, so here we have two parts. The first part, which is nothing but the coil is there, this is called the stationary coil, where the stationary coil will act as an electromagnet, and here you can see here inside you have a moving iron. So inside you can see where the spindle is attached, so this is called the spindle or the pointer. So inside you can see the inside of this stationary coil you have a moving iron instrument. This moving iron instrument works on the principle called attractive type. Okay, so the stationary coil north is developed, and here in the iron core south is developed. Automatically both gets attracted, automatically the deflection torque. Okay, so you can see here, as soon as you give the original supply, the pointer starts moving, so this torque is called deflection torque. As soon as you remove the deflection torque, as soon as you remove the supply, automatically it comes to 0, where this torque is called control torque. Okay, so here this is made up of an electromagnet. So this electromagnet will produce the electromagnetic damping in such a way that the needle will not oscillate like this, and originally it will come, and if you want to show to 3 amperes, it will show 3 ampere and it will stop, so it will not oscillate at this point. Okay, so if you how to suppress these oscillations is by providing an electromagnetic damping torque. So these are the simple parts. Only just you have to understand this stationary coil is nothing but field winding, and here this is nothing but armature. We don't call it as armature, it's like a small moving iron. Why it is called moving iron means this is able to move, okay, from 0 to 180 degrees. That's why this is called as a moving iron instrument, and here this is an example of an attractive type. So the scale is non-uniformly distributed. This is a simple construction of an ammeter. Now let us try to see what are the parts we have at the back. So this is nothing but if you are connecting to 5 ampere, from 5 it directly goes to one port, for the 10 it goes to the another port. This is nothing but the neutral. Okay, so that's how we can measure 5 amperes rating as well as 10 amperes rating. So this is the constructional details of an moving iron instruments. So thank you for watching. We'll meet about the wattmeter in the upcoming video. Thank you for your time.